Things have been looking pretty normal up there in the night sky. The moon, hanging around Earth, doing its thing. But what if one day we woke up and it was just gone? I'm talking completely vanished. No more moonlight, no more tides, no more lunar eclipses. Let's see what would happen if our celestial neighbor suddenly disappeared. And once the moon is gone. This is what if, and here's what would happen. Okay, before we explore the chaos that would ensue if the moon vanished, we need to understand what the moon actually does for Earth. The moon is Earth's only natural satellite. It's about 1/4 the size of our planet, which makes it unusually large compared to other moons in our solar system. For reference, it's 3,474 kilometers, 259 miles, in diameter. The moon is 384,400 kilometers, 238,855 miles, away from Earth, which is about 30 Earths lined up side by side. The moon formed around 4.5 billion years ago, likely from the debris of a massive collision between Earth and a Mars-sized object. That's why the moon and Earth share similar composition. Though the moon looks pretty substantial when it's full and bright in the night sky, it's actually only about 1/80th of Earth's mass. Still, that's enough to have a significant impact on our planet in several ways. The most obvious thing the moon does is light up our night sky. It doesn't generate its own light, of course. The moonlight we see is just reflected sunlight. The moon reflects only about 12% of the sunlight that hits it, which is why it appears grayish rather than bright white. Without the moon, our nights would be significantly darker. The full moon provides about 100,000 since the brightness of the sun, which doesn't sound like much, but it makes a huge difference on a clear night. But the moon's influence goes way beyond just lighting up the night. It's constantly pulling on Earth with its gravity, which creates the tides in our oceans. The sun also contributes to the tides, but the moon's gravitational effect is about twice as strong because, even though the sun is way more massive, it's also much further away. The moon's gravity pulls the water on the side of Earth facing it into a bulge, while on the opposite side of the planet, the water also bulges outward due to inertia. As Earth rotates, these bulges move around the planet, creating high and low tides. The moon also helps stabilize Earth's rotation. Our planet is tilted at about 23.5 high degrees relative to its orbit around the sun. This tilt gives us our seasons. Without the moon's stabilizing gravitational influence, Earth's tilt would wobble much more dramatically over time, potentially causing extreme and unpredictable climate fluctuations. Okay, now let's get to the fun part. What would happen if the moon suddenly disappeared? The first and most immediate effect would be on the tides. Within a day of the moon's disappearance, tidal ranges would decrease by about 75%. We'd still have some tides due to the sun's gravity, but they'd be much weaker and would occur only once a day instead of twice. Coastal ecosystems that depend on the regular ebb and flow of tides would be thrown into chaos. Many species of marine life synchronize their breeding cycles with the tides, so their reproduction would be severely disrupted. Next, our nights would become a lot darker. Without moonlight, nighttime illumination would drop dramatically. For most of human history, the moon has provided a natural nightlight, allowing people to navigate and perform certain activities after sunset. Nocturnal animals that rely on moonlight to hunt or avoid predators would have to adapt or perish. Some might thrive in the new, darker conditions, while others would struggle. The lack of moonlight would also affect plants that use lunar cycles for flowering and pollination. But wait, it gets worse. Over time, Earth's rotational stability would begin to degrade. Without the moon's gravitational pull keeping our planet's wobble in check, Earth's axial tilt would start to vary more widely. These variations wouldn't happen overnight. They'd take thousands or even millions of years to become severe. But, eventually, our planet's tilt could swing from nearly upright, which would minimize seasonal differences, to almost on its side, which would create extreme seasons, with one hemisphere facing the sun for months at a time, while the other experiences prolonged darkness. For reference, Mars, which has only 2 tiny moons that don't exert much gravitational influence, has seen its tilt vary between 15 and 35 degrees over millions of years. Earth's tilt variations would likely be even more dramatic without our sizable moon. The changes to Earth's rotation would also affect day length. Currently, Earth completes one rotation every 24 hours. But without the moon's gravitational influence, which actually slows down Earth's rotation through tidal friction, our planet would eventually spin faster. Days would gradually become shorter, though this change would be extremely gradual. We're talking maybe half an hour or so over millions of years. Now let's think about the cultural impact. The moon has been a central figure in human culture, religion, art, and science for as long as we've existed. Ancient calendars were based on lunar cycles. Many religions incorporate the moon into their belief systems and ceremonies. Without the moon, huge parts of human culture would need to be reimagined. No more full moon festivals, no more romantic moonlit walks on the beach, no more werewolf movies. Well, maybe that's not such a bad thing. Okay, here's something you might not expect. The sudden disappearance of the moon would actually affect Earth's orbit around the sun. The Earth-Moon system orbits around a common center of mass, or barycenter, which is located about 4,700 kilometers, 2,900 miles, from Earth's center. That's actually inside Earth, but not at its center. If the moon suddenly vanished, Earth's orbit would shift slightly as it adjusted to the loss of this gravitational relationship. The effect would be small, but measurable. So, talk about a cosmic shake-up. The disappearance of the moon would initiate a cascade of environmental changes. Without the moon's stabilizing influence, Earth's climate would become less predictable over long time scales. The weakened tides would alter ocean circulation patterns, potentially affecting global heat distribution and weather systems. Marine life that depends on tidal cycles for feeding, reproduction, or migration would face significant challenges. But here's the thing. Humans are remarkably adaptable. We'd figure out ways to deal with the darker nights, like developing better artificial lighting. We might create new cultural celebrations to replace lunar-based ones. Our navigation systems, which once relied heavily on the moon's predictable movements, have already been largely replaced by GPS and other technologies. The most severe effects of the moon's absence, like the increasing instability of Earth's axial tilt, would unfold so gradually that we'd have time to develop technological solutions or simply adapt to the changing conditions. What about space exploration? The moon has been a key stepping stone for human ventures into space. It's relatively close, has no atmosphere to complicate landings, and provides a platform with lower gravity that makes launching spacecraft toward more distant targets easier. Without the moon, our approach to space exploration would need to be reimagined. The focus might shift more directly to Mars or to establishing orbital space stations as intermediate destinations. Now let's talk about how the moon might disappear, because that matters too. The scenario we're discussing, the moon suddenly vanishing without a trace, is physically impossible according to our current understanding of physics. Matter and energy can't just disappear. But for the sake of this thought experiment, let's consider some slightly more plausible, though still extremely unlikely, scenarios. One possibility is that the moon could be knocked out of Earth's orbit by a collision with a massive object. like a rogue planet wandering through our solar system. If such a collision occurred, it wouldn't make the moon disappear, but it could send it hurtling away from Earth. The result would be catastrophic. The collision itself would likely send massive amounts of debris toward Earth, potentially causing extinction-level impacts. The gravitational disturbance would wreak havoc on Earth's orbit and rotation. Another scenario is that the moon could be gradually pulled away from Earth by the gravitational influence of a passing celestial body. This would be less immediately catastrophic than a collision, but the gradual weakening of the moon's influence on Earth would still lead to all the effects we've discussed, just occurring more slowly. But here's a wild idea. What if we somehow managed to move the moon ourselves? As our technology advances, there are serious discussions about planetary engineering, deliberately altering celestial bodies or their orbits to achieve certain outcomes. While we're nowhere near having the capability to move something as massive as the moon, future civilizations might develop such technology. They might decide to relocate the moon for some reason, perhaps to position it in a way that better serves human interests, or to harvest its resources more efficiently. Okay, now let's dig into something a bit more technical. The moon doesn't just affect Earth's tides and rotation. It also protects our planet from some of the debris floating around in our solar system. The moon's gravity captures some of the asteroids and meteoroids that might otherwise hit Earth. Its surface is covered with craters from billions of years of impacts. Without this celestial shield, Earth might experience more frequent meteor strikes, though the difference would probably be minimal given Earth's much stronger gravitational pull. Let's be real, though. The odds of the moon disappearing are virtually zero. In fact, the moon is actually moving away from Earth at a rate of about 3.8 centimeters, 1.5 inches per year, due to the ongoing effects of tidal friction. Eventually, we're talking billions of years in the future. The moon will reach a stable orbit much farther from Earth than it is now. By that time, the sun will have likely expanded into a red giant and engulfed both Earth and the moon anyway. So we've got bigger problems to worry about. But wait a minute. What about the tides and marine life? Without the moon's gravitational pull creating strong tides, many marine ecosystems would collapse. Tidal zones, those areas between high and low tide marks, are among the most biologically diverse environments on Earth. Species that live in these zones have evolved to thrive in the rhythmic flooding and exposure created by the tides. Without the moon, these habitats would be significantly reduced, and many species would likely go extinct. The effects would ripple throughout the ocean food web. Many marine species use the tides for reproduction, feeding, or migration. For example, horseshoe crabs in the eastern United States time their spawning to coincide with the highest tides of the full and new moons. Without these pronounced tidal cycles, their reproduction would be compromised. Similarly, coral reef spawning is often synchronized with lunar cycles. Now, let's think about something that might not be so obvious: the impact on Earth's magnetic field. While the moon doesn't directly affect our planet's magnetism, changes in Earth's rotation and internal dynamics resulting from the moon's disappearance could potentially influence the geodynamo, the movement of molten iron in Earth's outer core that generates our magnetic field. This is highly speculative, but if Earth's rotation were to speed up significantly over time, it might alter the convection patterns in the core, potentially affecting the strength or configuration of the magnetic field. This field is crucial for protecting life on Earth from harmful solar radiation, so any change could have significant implications. Earth's magnetic field also influences the behavior of many animals. Some birds, sea turtles, and certain bacteria use magnetoreception, the ability to detect magnetic fields, for navigation. If the moon's disappearance led to changes in Earth's magnetic field, these creatures might lose their ability to Navigate effectively. We should also consider the psychological impact on humans. The moon has been a constant companion throughout human evolution and history. Its regular phases have provided a reliable cosmic clock. Many people feel a deep connection to the moon, and its absence could trigger widespread psychological distress, a kind of collective grief or cosmic loneliness. We might even see the emergence of moon absence anxiety disorder, or something similar. The disappearance of the moon would also have practical implications for astronomy and space exploration. The moon provides a convenient reference point for astronomical observations. It's also a potential staging area for deeper space missions, and a source of resources that could be used for spacecraft fuel or construction materials. Okay, we've covered a lot of ground here. If the moon suddenly disappeared, we'd face shorter days, weaker tides, darker nights, and eventually more extreme seasons due to a wobbling Earth. Marine ecosystems would be thrown into chaos, human culture would need some serious revisions, and we'd probably all feel a bit lost without our familiar celestial neighbor. And just as a reminder, this whole scenario is physically impossible. The moon isn't going anywhere. But what if, instead of the moon disappearing, a second moon suddenly appeared in Earth's orbit? What would happen then? Well, that sounds like a story for another What If.